Hello everybody, welcome to the course VLSI Design Flow RTL to GDS. This is the 39th lecture. In this lecture, we will be discussing placement. In the earlier lectures, we have seen that physical design is broken into multiple tasks which are shown in this figure, and in last two lectures, we had looked into chip planning. And after chip planning, the next task is placement. So, in this lecture, we will be discussing placement, and specifically we will be discussing these topics: global placement, legalization and detailed placement, scan cell reordering, and spare cell placement. So, let us first look into what does a placement do. So, the placement basically decides the location of standard cells. In the last lecture, we had looked into chip planning, and there also we had looked into the placement of larger entities. So, it is important to distinguish that what does the placement do. So, placement is basically deciding the locations of standard cells and not of larger entities. So, the larger entity, this is P3 and this is P4. Now, we are asked the question, what is the half perimeter wire length estimate for this net N, right. So, first what we need to do is that we need to have a bounding box or rectangle which encloses all these pins, right. So, this will be the bounding box, right. So, we have created the bounding box by looking at the minimum and the maximum coordinates of these points, right. So, this is the bounding box we have got. Now, for this bounding box, we compute the half perimeter. So, half perimeter means that if we count from here to here, right, either this path or this path, it will give the same length, right. So, we count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, the semi perimeter or half perimeter wire length estimate for this net N is 11, right. So, this is how the wire length estimate can be made for a given net, right. Now, this is a very simple method, or half perimeter wire length method is the most simple and widely used also. There are more sophisticated method of finding a good wire or more accurate wire length estimates. So, now how do we do the placement, right. So, what is the technique of doing global placement, right. So, the placement problem has been studied since long, maybe since 1970s, right, and it is known that it is a difficult problem, it is an NP complete problem, right, and therefore, a lot of heuristics have been developed over the years, last 50 years or so, for the placement problems, right. So, various heuristics have been proposed, and these heuristics work in good in some designs and may not work very well in other kinds of design. So, typically these days the most widely used heuristic of placement is what is known as analytical placement algorithm, right. So, in analytical placement algorithm, or the way of or the method of placing cells analytically, what we do is that we consider each cell as a point